Hello everyone, this is Siddharth Singh Parihar and I am going to teach you microprocessor and its applications. Today's topic is RS-232 protocol or standard part 2 and this topic belongs to lesson plan number 36. Let's start. In the previous lecture we saw basically electrical and mechanical specification of RS-232 standard. Now we will see functional and procedural specification and how RS-232 works. Okay, so as of basically RS-232 is considered a complete standard. It defines more than electrical and mechanical characteristic. Okay, so basically in functional description or specification, the signals are classified as common signals such as ground, data, timing and also control signals. While in procedural specification, if we assume computer is a DTE device, that is data terminal equipment, is connected to a modem DCE, which is data communication equipment through RS-232 interface. So if we want to send the data from computer to modem, then the following procedure must be followed. Initially, when modem, that is DCE, is ready to receive, it will send a DCE ready signal, that is data communication equipment ready signal to computer. And when in the second step, when the computer, that is DTE data terminal equipment, is ready to send the data, so it sends a ready to send signals to modem, that is DCE. The modem then sends a clear to send signals, that is indicate to DTE that data can be sent by computer. Finally, in the last step, the computer, that is DTE data terminal equipment, sends data on transmit data line, that is TD line, to modem, that is called DCE. So students, here it is important to understand this is not the exact procedure, but this is similar to the actual one which exists. Okay, so how we go for practical implementation of RS-232 standard? As we know, the voltage level of RS-232 standard are very different for most of the system we used today. So we need a level converter, that is some sort of implement RS-232 interface, and this is done by a IC named as MAX232 by Maxim Integrated. So these ICs takes RS-232 signals and generate equivalent TTL level voltages. Okay, so here in this diagram, the digital data transmission using modem and standard telephone lines are shown below. In this diagram, you can see it is a computer that uses UART, that is Universal Asynchronous Receiver Transmitter, and this is basically a synchronous controller, and it has 8 pins, that is TD, RD, RTS, CTS, DSR, DCD, DTR and RI. While in the other side, serial port which belongs to modem, and we use DP9 connector that has 9 pins, TD, RD, RTS, CTS, DSR, ground, DCD, DTR and RI. So basically these both UART and DP9 connector are interfaced with each other with the help of RS-232 driver, that is manufactured by Maxim Integrated. Okay, and in this half we know that we use TTL or CMOS logic labels, while in modem side we use RS-232 standard, that is -3 volt to plus -15 volt, and plus 3 volt to plus 15 volt, while minus 3 volt to plus 3 volt voltage level are not used. So basically we can say that minus 12 volt is used for logic 1 and plus 12 voltage level is used for logic 0. Okay, so the UART generates and receives the necessary signal for serial communication, and RS through 232 driver is basically responsible for converting these signals between TTL and RS232 interface. Okay, and in this example we use asynchronous type, and basically if you use asynchronous data transmission, then we use a synchronization bits like start bit, stop bit, and something error checking bit, that is parity. Okay, so UART in the above example is responsible for generating the start, stop and parity bits when transmitting the data, and also detecting errors, generally single bit error, while receiving data. Burst error cannot recognized, so I am not mentioning here for burst error, but yet we detect single bit error and correct them. Okay, so some sort of error correcting codes used in between UART and modem. Okay, so after how RS232 works basically. So in RS232 standard we use asynchronous transmission. So we use start bit, parity bit, which is error correcting bit, and something stop bit. So in this example we can see we use, as we discussed earlier, we use start bit as a 0, and we use stop bit, 1 stop bit, 2 stop bit, or 2.5 stop bit. So basically in this example we use 2 stop bit S1 and S2, 1 parity bit which is used for error correcting. Okay, and these are our basically data, and the MSB of this data frame is called start bit, which is represented by 0. So in this example we can see we use 0 as a start bit, and this is for data, and we use 2 stop bit 1 1 and 1 parity bit 1. 1 parity bit 1 identifies the number of ones in our main data stream is odd. So we can see here the number of bits, because we have MSB here for our main data and LSB here for our main data. So the number of ones is equals to 3, which is odd. That means our parity bit is set to 1, while we have 2 stop bits 1 and 1, and this is our data, 8 bit data 10000011. Okay, so this basically first the transmitter after the terminal power is turned on, the terminals runs any self check. It asserts actually the data terminal ready, that is DTR signal, to tell the modem that it is ready, and when modem is ready, then it transmit or receiving the data. It asserts the DTR signal to the terminal. Okay, after receiving DTR, the DTE request use of data channel by asserting RTS signal to start the transmission. The modem at the receiving end is then dialed. Okay, so when the modem connected to sending terminal receive this carrier, it assert carrier detect, that is CD, to the terminal. After proper time interval, the modem sends clear to send, that is CTS signal, which indicating modem and communication channels are ready for transmission. Okay, so immediately after CTS signal is generated, the terminal at the transmitting ends sends serial data on its TD output. So a similar handshake take place for receiving data. Okay, so this is the flow chart which shows a handshaking process. So we use asynchronous mode of transmission. So handshaking required, basically in asynchronous transmission there are three basically modes which are used in RS-232 standards. So these are no handshaking, hardware handshaking, or software handshaking. Okay, so this is basically the flowchart of handshaking signals. So we start. So at first, basically output DTR is low. That means this specifies the data terminal equipment is ready. Okay, and after the DTR signals, check if the modem is ready or not. So read DSR data set ready from modem. So we know, or we have seen here, DSR is a low signal. Then it is low, then the modem is ready. Otherwise, if it is no, then our modem is not ready. So we are again flip back to this step. Okay, and it continuously monitor that DSR or our modem is ready or not. If it goes, DSR signal goes to low, then it is ready. If it is ready, then it prepares for transmission, including it initialize pointers and counters for the text to be transmitted basically. So after the preparing for transmission, the RTS signal goes to low. This indicates the DT request use of data channel to begin transmission. After reading CD bar signal from modem, that indicates it makes sure that modem has made contact with remote modem. If CD signal goes to low, then it switches for reading the CTS signal which generates from modem, and if no, then it basically wait until the remote carrier is detected. This CD belongs to carrier detection. Okay, so if yes, then basically it reads CTS signals from modem, and if it goes low, then wait for modem to be ready. If yes, then transmission begins, and if no, then again it monitors. When CTS signal goes low, the modem and communication channel are ready for transmission. Okay, so this is the flowchart which are used or define the works how RS-232 works. Okay, so basically there are three types of handshaking in asynchronous mode, as we can discuss earlier. First is no handshaking, the second one is hardware handshaking, and the third one is software handshaking. So if handshaking is not used, then it is compulsory to receiver, then it must read the data that is already received by it before the transmitter, or we can say that data terminal equipment sends the next data. Okay, for this purpose the receiver uses a special memory location called buffer. So in this figure it is clear we have a transmitter buffer and the receiving buffer. Transmitter buffer having a data which is being to be transmitted, while in receiving buffer it contains data which is received. So when in the transmitter end we use transmitting buffer, and the receiving end we use receiver buffer. So when we not use handshaking techniques, so it must be compulsory for transmitter or receiver being perfectly synchronized in terms of timings. That means the receiver must read the data that is already received before the transmitter send the next data, because it have some issue of failed the next bit. Actually Here in this diagram, the transmit send one bit from transmitter to receiver, and the second bit and the third bit. Suppose we have 4 bit in our data, but if they are not synchronized in terms of timing, then the fourth bit is not recognized or read by the receiver, and it override by the next bit, or we can say that the fifth bit, which is coming from the transmitter. So we lost our fourth bit. This is the problem when handshaking is not used. So when handshaking is used, these problems are sought out. So these types of problem is overcome by hardware handshaking and software handshaking. Hardware handshaking basically protocols defines 4 signals for the purpose of handshaking. In hardware handshaking, the transmitter first asks the receiver whether it is ready or to receive the data. The receiver then checks its buffer, that is receiver buffer, and if the receiver buffer is empty, then it will tell the transmitter that it is ready to receive the data. The transmitter will transmit the data after that, and it is loaded into receiver buffer. During this time, receiver tells the transmitter not to send any further data until the data in the receiver buffer has been read by the receiver. This process is complete by 4 signals, that is ready to send RTS, clear to send CTS, data terminal ready DTR, and data set ready DSR. And these are the figure which including a transmission between DT and DC devices. Here we use DP9 as a DP9 connector as a DC equipment, while here we use DP25 connector as a DC equipment. Okay. In the software handshaking, in RS-232 involves basically 2 special characters, that is X on or X off. X on belongs to transmitter on and X off belongs to transmitter off. When the receiver sends an X off signal, the transmitter stops the sending the data to receiver. The transmitter starts sending data only after it receives the X on signal. As you can see in this diagram, transmitter sends a data to receiver. Okay, these are the transmission of data from transmitter to receiver. But once a receiver generates an X off signal, that is used to tell the transmitter not sending any data. Okay, so transmitter stops the data transmission, that is it doesn't transmit any data to receiver until or unless when it received X on signal from the transmitter. Once transmitter receives X on signal from the receiver, then it further transmit the data to receiver. Okay, so with the help of software handshaking and hardware handshaking, we remove timing synchronization problem between the transmitter and receiver. Okay, so that's it for RS-232 standard of protocol, and if you have any doubt, then please ask me in doubt session. Okay, thank you, have a nice day.